Okay, here's the plate. This is going to be the bottom plate that's now in the vise, ready to start machining. First thing I'll be doing is getting the X and Y 0 points using the touch gauge right there. Okay, finish pass is complete. Let's do the flanges. Okay, here's the top plate right here. These are the holes for the motor to connect up to, and the motor. This is a car seat motor, and as you can see right here, it uses a worm drive, and you can see the connections right there. One is kind of wider than the other, and that's mirrored on here. The reason it's rotated is you can see this motor where the axis is right here, the axis is here, the motor's offset from that. So what happened was this portion of the motor was actually hitting the side of this piece right here. So what I've done now is I've rotated that by 15 degrees to get that out of there. Now what I'll be doing is taking these bushings right here, and they'll get pressed into the various the 3 spots. Then we'll be able to start testing. We've got here is this piece right here. Actually, if I rotate it, this is more or less the way it actually goes. This is the pivot point for this. This is the piece that will actually pivot 120 degrees. This gear, this is steel gear that I had to machine down to fit. It's bolted in place with these 2 screws from the back side. It's drilled and tapped. The reason there's holes on both sides is that I'll actually be only using half this gear, so I'll be cutting this off right down the center here, and now that's ready to go for the a second leg. So this is one way to save a little bit of money, since I 180 degrees worth of gear and I only really need 120 degrees. Now here is a This is a steel shaft, quarter-inch shaft, and it's got the gears on here. This is a 12-tooth gear on the bottom right there with a 30-tooth gear right there. This basically is going to interconnect. The 12-tooth interconnects with this 48-tooth gear right here. That gives one set of reduction. This 30-tooth gear will actually go and connect to another 12-tooth gear, which goes on the shaft of this motor drive. This shaft was actually about a 1/2 inch diameter originally. Had an unusual Acme thread on it that I disassembled the entire assembly, put this in the lathe, and took it down to 1/4 inch so it would fit what I need now. So next thing to do now is to go ahead and use the arbor press to get these in place. Alright, so now this has been pressed in, and you can see it's a nice smooth fit right there. Again, these are oil impregnated bushings, so they actually will that'll help from a lubrication standpoint. Okay, this is the gear motor now attached, and you can see it comes up through the center of that hole right there. It's got a couple standoffs because of the size of the motor versus the plate, and keep that from interfering. Alright, this is the gear train with the bottom plate put on, and it's aligning up pretty good right there. It feels it rotates pretty easily. Of course, right now it's just, there's no pins in here there'll be roll pins through the shaft to hold those in place. Okay, here's the gears all put together, and everything is pinned. I've actually put some power onto it, and it moves pretty well. Obviously these two plates are just kind of floating loose, so there's some vibration in there, but when it's ready to go, it won't have that. So let's see if I can do this one-handed to put some power on. There we go. You can see we got a pretty fast motion from one side to the other. So there we go. So this is the gear setup. Now, yet to put on the optical encoder. So that'll be going on next. Alright, now what I'm doing is creating the mandrel that the optical encoder disc will fit on. This is the optical encoder disc, and the I need to make this the same diameter as that, and this is the lathe. This is a piece of aluminum I already had before, and I've already cut the 1/4 inch diameter hole in it. And now I'm going to go ahead and have this thing run. The CNC mill, or lathe, excuse me, and you see it cuts very nicely. And lots of aluminum scrap here, so I'll be doing a lot of these cuts to get it down to the appropriate size, and then do a lot of measuring to make sure I got it right. Alright, here's the new mandrel. It has 1/4 inch hole through the middle. The encoder portion of it is all fits on there. It's got a little shoulder there. The little hole right there is for a set screw to set it on the shaft. So this, again, this is going to go on the shaft for the motor.